Hi, and welcome to Web3 Unfiltered, the podcast where we cut through the noise, the jargon, and the speculative hype to deconstruct the mechanics of the decentralized economy. I am your host, Collins Victory Odabi. On this episode, we are diving into a logic puzzle that kept computer scientists awake for decades. If you've ever wondered why we need things like mining or staking, it's because of this one problem. It's called the Byzantine Generals Problem. Here's the hard truth. In any decentralized system, whether it's a group of generals on a battlefield or a network of computers around the world, the biggest threat isn't a technical glitch, it's treachery. Imagine a group of Byzantine generals surrounding an enemy city. They can only win if they all attack at the exact same time. If some attack and others retreat, they will be slaughtered. But here's the catch. The generals are separated by distance. They can only communicate by sending messengers. Now, the problem isn't just that a messenger might get captured. The problem is that one or more of the generals might be a traitor. A traitorous general could send an attack message to one group and a retreat message to another, causing total chaos and a systemic failure of the mission. So, how do the loyal generals reach a consensus when they don't know who is telling the truth? This isn't just a history lesson, this is exactly how a blockchain works. In a network like Bitcoin or Ethereum, every node is a general, every transaction is a message. So, how do we ensure that every computer on the planet agrees on who owns which coin, even if some of the computers are run by hackers or traitors? Before Web3, the answer was simple: you use the king. In the financial world, a king is a bank. The bank tells everyone the truth, and if you don't like it, too bad. But that's a single point of failure. If the king is corrupt, the whole system is corrupt. So, to build a decentralized system, we needed a way to achieve Byzantine Fault Tolerance, or BFT. This means the system continues to work, even if a large chunk of the participants are acting maliciously. So, for over 30 years, we had theoretical solutions, but they were slow and required everyone to know everyone else. Then came the strategic breakthrough of Satoshi Nakamoto. He didn't just try to solve the logic with more messages, he solved it with cost. This is where the mechanic of proof of work comes in. In the Byzantine Generals Allegory, Satoshi basically said, to send a message, you must spend a massive amount of energy. By making it expensive to send a message, it becomes mathematically irrational to be a traitor. If a traitor tries to confuse the network, they waste a fortune in electricity with zero guarantee of success. The strategy here is brilliant. Call it incentive alignment. You don't need to trust the other generals if you know it's in their best financial interest to tell the truth. For the builders and architects listening, the key takeaway is this: trust is not a feeling, it is an architectural output. When you are designing a DAO or a protocol, you must assume that Byzantine actors are present. If your system relies on everyone being nice, you haven't built a Web3 protocol, you've built a house of cards. Solving the Byzantine Generals Problem is what turned the internet from a place where we share information into a place where we can move value. It is the bridge from a world of centralized kings to a world of decentralized consensus. So that wraps up today's episode of Web3 Unfiltered. We've deconstructed the logic of trust and how Web3 uses economic cost to solve a mathematical deadlock. If you found this episode valuable, don't forget to share it with your network and subscribe to Web3 Unfiltered so you never miss an insight. Until next time, stay sharp, stay curious, and keep building.